Now see here, this is a question here where you have to find out time period of the liquid column. So this is U tube you have taken here, and in this U tube liquid is filled up here. Length of the liquid column is L, area of cross section of the tube is capital A, and rho is the density of the liquid. Now what happened here? If one side you push this liquid by a displacement y, then it rises to this side by a displacement of the y here above the C. Now, but from this line, equilibrium line, it becomes 2y. So, because of this 2y length of the liquid column or the weight of the 2y length of the liquid column, a restoring force comes into action. Because of this restoring force, liquid starts oscillating in this U tube. So, we have to get here the time period. So, basically what is the cause of the restoring force? Cause of the restoring force is the weight of the liquid in 2y length of the column. So, we can write restoring force is equal to 2y is the length. So, we can get the volume. So, area into length is volume into density is mass, and here into g, that is the total weight, and it is here minus here because it is acting as restoring force. So, we can write F is equal to minus twice of A rho g into y. This is constant. So, we can write F is proportional to minus y. That motion is simple harmonic. So, we can get here the time period t is equal to 2 pi under root of m upon k. In place of k, we can get here this one because F is equal to minus ky. So, we can write t is equal to 2 pi under root of m upon twice of A rho g. Now, mass of the liquid also we can here replace. We can write m is equal to A L rho g. Here this is small l, the total length of this. So, if you put here the m, we will be getting t is equal to 2 pi under root of A L rho upon twice of A rho g. This A will get cancelled, this row will get cancelled. You will be getting 2 pi under root of L upon twice of g. So, this is the formula for the time period. So, we can also calculate frequency because frequency is equal to 1 upon t.